printing hello world to the screen is tradition when learning a new programming language, because it's usually the simplest program you can write. In Python, easy, just write print hello world. In JavaScript, use console log. C, C3, Rust, Odin, Gleam, Java all have some print function that is easy to use. Even modern C++ has a print function. But if you try to learn Zig, bam, you meet this. Try stdio file, std out, write streaming all, init.io, hello world. What the hell? I thought Zig was a simple language. So why does it look so complicated? Well, that's because Zig is indeed a simple language. It doesn't have a lot of keywords or concepts to learn, but it requires a good understanding of how computers work. The language doesn't hide the complexity of the underlying systems. It gives you more power, but it's less convenient to use. In this video, I will try to explain what's going on, but there's a non-zero chance that you will get even more confused. But what's the fun if there's no danger? All programs need an entry point. In Zig, it's the main function. This function is actually called by a function named callMain, defined inside std/start.zig. So to be callable, the function needs to be marked pub for public. It can take 0 or 1 parameter. The parameter can be of type std_process.init.minimal or std.process.init. That's what the hello world uses, and it comes with some juicy stuff, including 2 allocators, environment variables, command line arguments, an IO implementation, and more. That's why it is referred to as the juicy main. I will talk about the return type of the main function later, so let's focus on the first line. We create the constant std by calling the function @import_std. In Zig, all built-in functions start with an symbol, and @import is the built-in function to import other source files or modules. Here we import the standard library module. A module is just a collection of source files, one of which is the root source file. For std, it's this one, std.zig. It makes everything publicly available. One interesting fact about Zig is that every Zig source file is implicitly a struct. You can imagine the content of a file to be surrounded by a struct. So when you do const std equal @import_std, it's almost like creating an instance of a struct. But if a struct doesn't have fields and isn't meant to be instantiated, like a regular struct, then it's considered to be a namespace only. Only because all structs or really any user-defined types also act as a namespace. The std.zig file doesn't have fields, so it acts as a namespace and it gives you access to all the public functions and types defined in this file. A counterexample of this is the io.zig file, which has 2 fields and is meant to be instantiated. The easiest way to tell if a file should be considered a type or namespace is to look at its name. Types use title case, while namespaces use snake case. Inside the main function, we use the std constant to call the function stdout. But to do that, we first need to traverse the IO and the file namespaces. If we look inside std.zig, we can find the IO declaration. It imports the io.zig file. Inside it, we find the file, which is another import. And inside std.io file.zig, we find the std function. So std.io.file.stdout calls the stdout function defined in std/io/file.zig. This function returns a file because on Unix-like systems, the standard IO streams are exposed through file descriptors. So using a file to write to stdout is the correct abstraction. The file type has the write streaming all function. When a function is defined inside a struct, if the first parameter has the same type as the struct, then we can use it like a method. That's why we can change the write streaming all call to the stdout call that returns a file. But we could have perfectly passed this file as an argument instead. The third parameter of write streaming all is a slice of bytes. Here we give it the string literal hello world. Zig doesn't have a string type, mostly because strings are complicated and probably a bit too high level. So Zig represents string literals as constant single item pointers to null terminated byte arrays. Oof, that's a tough read. Let me explain. Zig makes the difference between pointers pointing to a single element and pointers pointing to an unknown number of items. Here, if we look at the type of the hello world string, we see that it's a single item pointer to some complicated type t. This type t starts with a const, so it's immutable. Then this syntax means that it is a zero terminated array of 14 U8. 14 because the string is made of 14 ASCII characters. The \n is a single character, but the 0 is added at the end as a 15th byte. 0 in ASCII corresponds to the null character. That's why we talk about null terminated strings. We can actually verify this by building the program into an executable using zig build.exe and opening it in a binary editor like JX. We can look for hello world, and we can see the 14 bytes of the string followed by a 0. Okay, but if we go back to the definition of write streaming all, it expects a slice of bytes, not some single item pointer to an array. But that's not a problem because a slice is just a pointer and a length. So Zig has no problem converting this type into a slice. And if you're curious, we can look at what's really happening by rebuilding the executable with zig build.exe and emitting the corresponding assembly using the flags llvm and emit asm. Then we can look for the string hello world inside the assembly file using grep or ripgrep to get the line number where it's defined. Then we can take a look around it using sed. We can see that it creates an anonymous object in the read-only data section and emits an ASCII string terminated by a 0 of size 15. Now we can look for this symbol using grep. It's used only once, and once again we can see the lines next to it using sed, and we see that before calling the write streaming all function, it first passes a pointer to the string and passes the length 14 as arguments. See, I didn't lie. The slice is a pointer and a length. The length is 14 because it's not going to write the 0, so we can just forget about it. Oh, and you may be a bit surprised to see that arguments are stored in registers and not in the stack. It's not that people who taught you that are wrong, but it depends on the calling convention, and on Linux, 64 bits, the 6 first arguments of type integer or pointers are passed via registers. But if you have more, they will be pushed onto the stack. Okay, let's move on to the I/O parameter. In version 0.16, Zig introduced this new I/O interface. If you look inside, you will see a lot of functions, but you will also see a big vtable with a lot of function pointers. The goal of this interface is to abstract all I/O operations like dealing with files, networking, processes, async await, and more, such that we can write code that works for all possible concurrency models. You know, all the operations I've listed block the main thread of execution. Whether it's waiting for a database request to complete or writing to a file, the idea behind the I/O interface is to define all the primitives that these blocking operations need and to gather them in a sort of backend that you can easily change according to your needs, so that you can decide to use a thread pool, a single blocking thread, or something like I/O urling. It also means that if you have some custom hardware or operating system, you can implement your own I/O strategy. And all the code in front of it will still work. Any library, any function, everything will just keep working fine. That makes code extremely reusable. You just have to write it once and it works everywhere. But you need to pass the I/O implementation as an argument. And in our hello world, it comes from the init argument received by the main function. If you want to learn more, I've already made a dedicated video about it, and we'll probably make more. Let's now look at the return type of write streaming all. This is an error union type. In other words, this function can either return nothing or an error of type writer.error. Zig, like many modern programming languages, shows errors as return values to force you to handle errors. So if a function can fail, you know about it and you can't just ignore it. This helps writing more robust software. A function will not fail silently and make your program unstable unless you decide to make it that way. And the errors are pretty basic. They are defined in an error set, which is like an enum. Each error name gets assigned an unsigned integer greater than 0, and that's about it. Errors can't have payloads, it's by design. And in Zig, it's better to think of error handling and error reporting as two different things. And errors are for handling failure, for control flow. There are many ways to handle errors, but here, notice the try before calling the function. Try will extract the value if the call succeeds, otherwise it will return the error out of the current function. This is why you can see that the return type of the main function is !void. This is also an error union, but we didn't specify the error set. Zig will infer it for us. So if write streaming all returns an error, the main function will return that same error. And with that, we've covered this hello world program. I think it's actually pretty interesting because it shows that Zig is indeed made for maintaining robust, optimal, and reusable software. Robust thanks to the way errors are handled, reusable thanks to the I/O parameter, and optimal because here it's hard to really tell that it's optimal because write streaming all still does quite a lot. But if you dig a bit, you'll realize that more often than not, the Zig way of doing things is usually very sensible and well thought and optimal. It's part of the Zig Zen to provide only one obvious way to do something and may as well make it the most optimal way. Okay, bonus time. I've just said there's only one obvious way, but here we could be tempted to use write positional all instead. But if you do, you will end up making a useless syscall that will fail. Because you see, positional syscalls don't work on TTY. The more you know. Quiz time! Because apparently YouTube can let me add quizzes. I don't know how it works, so I don't know where you're supposed to answer, but you will figure it out. Yeah, you can do it. So the question is, do you know why this function is a while loop? Pause if you need to think about it. So pause now. Okay, you ready? Well, that's because the syscall only guarantees to write up to the number of bytes we give it. It may not be possible to run everything in one go, so you need to keep repeating the operation until everything is written. Alright, it's time to go to bitch. You know, I actually made this video because I was looking at the documentation and I was like, yeah, this hello world is pretty complicated. Like, it's not very appealing. And I've decided I was going to make way more video about Zig. I'm probably going to really focus on making Zig video for now. And I'm thinking about making a series to pretty much talk about everything about Zig. And yeah, will be nice. But I will take a break for, you know, summer, and I will come back. I will come back probably in September, maybe. I don't know. See you later. Alligator.